Hello, this is my soldering station, and there's one big problem with it: the lighting. You don't need to be an electrical engineer to see that the circuit is total and absolute trash. It uses some cheap SMD LEDs, haphazardly soldered onto a perf board, and connected to a phone charger through these wires, and then the whole contraption is turned on by this switch. And it creates a very meager light, which also just happens to be at a slightly wrong angle. So what I'll be trying to make is a lighting system which has a PWM or pulse width modulation dimming circuit, which then connects to a powerful LED array using some just cheap 5mm white LEDs. And then that will connect to a boost converter, and then finally to the phone charger. And I'll also design a 3D printed case which will allow me to adjust the angle of the LED array. So I've created a simple circuit which generates a PWM signal. So right here I've got a 555 timer which is configured as an A-stable oscillator, so it generates a triangle waveform at pin 2. So that is the blue line here. You can see it doesn't have perfect symmetry, but that doesn't really matter in this use case. This is then fed into an input of a comparator, which is then comparing that voltage against its other input, which is connected to this potentiometer here, which is configured as a voltage divider. So that means that if we turn this potentiometer, we can see that the voltage varies. And that is that purple line here. And then the comparator compares the two voltages and generates a PWM signal as a result. And then we can use this, for example, to control LEDs. So right here I've got a blue LED, and if we connect that to our output of the PWM signal, then we can see that the LED lights up. And by turning this potentiometer, we can dim the LED. This is favourable over, for example, changing the voltage, because different LEDs have a different forward operating voltage. Specifically, red LEDs have a lower one than a blue LED, for example. So this means that a red LED is going to be brighter at a lower voltage. So either you have to drive all the LEDs at a different voltage, or put a bunch of resistors of different values, which is super impractical. So instead, PWM signals are far more practical for this. For our LED array, we are only going to use one type of LED, a white LED, which is just a blue LED with a phosphor coating. So that doesn't really apply for this use case. But another advantage is, for example, if we are just creating a variable DC to DC converter, then that means that we can accidentally increase the voltage too high and then burn our LED, which of course we don't want. However, our PWM signal, you can see that it's loaded slightly here, so the voltage is lower than if, for example, we disconnect the LED. The LED is fed a specific voltage, which is the voltage fed into our circuit, and that voltage will not change even if we dim the LED, as you can see. So that means that it won't burn the LED if we accidentally turn our potentiometer too high. The circuit I will actually be using to drive this LED array that I'll be making won't actually be loaded like this at the output, because I'll use a MOSFET like this one, which will be able to drive the LED. These are really quite high powered ones, so that means that the voltage won't be loaded, as they have a really low RDS on resistance, unlike this comparator here. So then all I need to do is create this circuit on the perf board and add the MOSFET, perhaps some, for example, reverse voltage protection with a diode or something, and a linear regulator, and then I'll need to find some boost converter or buck boost converter in order to generate the 6. So I've designed a case for the LED array, and there's this little knurled knob and this mechanism which connects to this mount, and this allows you to change the angle that the LED array is pointing, and this is the other mount which connects to the other side. So after slicing it, I'm going to print this, and then we'll attach the LED array into the 3D printed case. So I've 3D printed the parts, and I've soldered the LED array, and it's going to be mounted up onto this cupboard with some double-sided tape. So I finished soldering the circuit. As you can see, we've just got a potentiometer, the PWM circuit, controlled by the potentiometer and this MOSFET here. It's connected up to this light, and I've just used the Sepic buck boost converter from Amazon from before. And the soldering station has changed a bit because my soldering iron broke, so I had to get a new one, and I rearranged a few things because I got some new magnets for my Gridfinity storage system. So anyway, let's see if this circuit works. So let's turn on power, and okay, it works. The light looks very blue, but that's just because of the camera, and as we can see, we can dim it. So yeah, all we need to do now is just make a case for it. In case the DC to DC converter overheats. So I've got a switch here, so let's see if it works. Okay, it works. It dims. The camera doesn't capture the light very well. It appears very blue in the camera. But in real life it looks better, and also the dimming doesn't look very nice with the camera, but again, in real life it's fine. You can see that there's a certain range in which the LED brightness won't change. That's because the triangle waveform generated by the 555 timer is not rail to rail, unlike the output of the potentiometer. If I wanted to fix that, I'd put a few resistors on either side of the potentiometer, but to be honest, can't be bothered. So yeah, there's that. And another thing is also, I was going to put an LED here as an indicator, but to be honest, again, too lazy to do that. The angle adjustment works and everything. Yeah, so that's that. This is quite a boring project, to be honest, but if you want to see anything more interesting, for example some high voltage stuff, then subscribe to the channel, because I've got some pretty powerful high voltage circuits that I've made, so you might want to have a look at that. Another problem I've just noticed with this whole LED array thing is that at certain powers it generates a high frequency sound. I think that's just a DC to DC converter misbehaving. Yeah, so stay tuned for the high voltage stuff.